Also that's joining us online. You'll see that you're all muted, and we'll ask everyone to remain muted throughout the duration of the seminar today. We will have an opportunity to ask questions through the chat at the end of Tejal's presentation. So without further ado, I'm absolutely delighted to welcome our speaker today. Tejal Kantikar is an associate professor in the Energy, Environment and Climate Change Programme in the School of Natural Sciences and Engineering at the NIAS, and has been a member of the Indian delegation to meetings of the UNFCCC and the IPCC. She is a mechanical engineer by training and has worked in the area of energy and climate studies since 2006. She works on the interconnected issues of energy production and consumption, environmental constraints and development, with a perspective that prioritises equity in the era of acute environmental crises such as climate change. Her work to date includes seminal analyses on the equity within global carbon budgets and global mitigation pathways, alongside integrated assessment modelling and power network planning. I'm absolutely delighted she's agreed to speak to us today. And the title of the presentation, Exploring Pathways to Equitable and Climate Compatible Futures. So Tejal, I'd like to invite you to share your screen and start your presentation when you're ready. Thank you very much.
Thank you very much. This is it's an absolute pleasure to be here and share this work with you. At the outset, let me say, can you see the full screen? I hope the presentation is visible. At the outset, let me say that the work that I will be presenting today is work that has been done in collaboration with my colleagues, T. Jayaraman, Akhil Maitri, and Ankita Ranjan, all based in different institutions in India. Since I don't have too much time, and I think I've been a bit ambitious in terms of what all I thought I could cover in the limited time that I have, I'm going to dive right into it. What I will speak about is first the larger policy context. Why is it so important to talk about models? Simulations of the real world modeling studies have been around for the longest time. Either to be able to help us plan in the short term, or for projections for all kinds of other reasons, in economics, in engineering, as well as in the physical sciences. Modeling has been very much a part of the way in which the academic community has tried to simulate the real world to a certain extent, with some assumptions, with some constraints, with some limitations, but nevertheless trying to understand what you can so that you can design interventions in the future. But in the context of climate change, and especially in climate policy, this is becoming increasingly important and an increasingly important element that drives policy, that has been presented in a manner that suggests that it should, in fact, drive policy. I'm not sure how many of you are aware, for example, of the latest decision from COP28, the 28th Conference of Parties under the UNFCCC. The decision on the global stocktake, for example, gives results. Some of the results that it talks about are from the global modeled pathways of the IPCC. And, there are numbers that are very much a part of these cover decisions. These are political decisions. How much of these numbers are understood by those who are negotiating these numbers? Everybody understands, I suppose, where they come from, but what are the assumptions that underlie some of these numbers? How well is it understood by all the people who are negotiating some of this text that is then presented as a political consensus to the rest of the world is not really very clear. I remember, many years back when I started working on this, I was a grad student, and I met some of the negotiators, and I was, presented an energy emissions model to them. I met some of the people who were the negotiators for India at that point of time. This was quite over a decade ago. And they said, no, this is great work. It's very good. But, the negotiations are not really about numbers. They're not about models. And this is fine in the academic sphere, but the negotiations are about, language, they're about text. That's why you have lawyers negotiating political text. They're about where you put a comma, where you put a full stop, and those kinds of things. So numbers are fine, but they're not really, going to be part of decisions in that sense. But now we are, almost 15 years ago, I heard something like that. And now we are at a situation where you actually have negotiated text that gives numbers in terms of how much you need to reduce emissions by 2030, how much you need to reduce by 2035, when should you reach net zero by, and so on and so forth. So it's become intrinsically a part of the way in which policy is conceived of and presented to the world. So the way in which I am going to divide my presentation is I'll talk about the context, then the problem with the current frameworks that are seeking to inform policy, and the possibility of other frameworks. And I will I propose that other frameworks are possible. The fact that there has been a lot of money invested in certain kinds of modeling approaches, which are really not fit for purpose, is not a reason why we should continue to put money in. Just because something has been done historically and it's available doesn't mean we need to continue doing it even in the future. If that were true, then we could just also continue using fossil fuels in the future. Right? So just because something has been done for a long period of time doesn't necessarily mean that that's the correct way of doing things. So let me start by saying that there has been quite a significant shift from the 5th assessment report of the IPCC to the 6th assessment report in terms of the focus of on either the concept of net zero or the concept of the carbon budget. The carbon budget as a concept, the near linear relationship between cumulative CO2 emissions and warming was well established in the 5th assessment report in 2013. That means the literature for it was available even before this time, since 2008, 2009. And intuitively, a lot of developing countries, in fact, had policy papers thinking about atmospheric space as in terms of a carbon budget, cumulative atmospheric space as a global commons much earlier, even before the science, on this was published in that sense. But we've known the science for a long time that it is in fact the cumulative emissions that directly determine warming, cumulative CO2 emissions. Of course, this is subject to non-CO2 forcings and uncertainties, but nevertheless, there is almost a near linear relationship between warming and CO2 emissions. And this is very clear in AR5. You don't really see net zero as a concept bandied about in AR5 as much. But from AR5 to AR6, you see this shifting. You see this focus shifting. And net zero, in that sense, implies that there must be a balance between the sources and sinks of carbon dioxide globally. Now, this graph that I'm showing here is basically a net zero by 2050. Okay. Starting now, if you have a linear reduction in emissions and reach net zero by 2050, you will cumulatively, that's the area under that curve, cumulatively emit 560 gigatons of CO2. That's more or less equivalent to, so 500 corresponds to a 50% probability of limiting warming to 1.5 degrees Celsius, around 500 gigatons of carbon. This is a number that's coming from the working group 1 of the IPCC's 6th assessment report. Right? So you can say, if, for example, countries say that, and that we will reach net zero by 2050. If I have to then make an assumption that you will, the pathway that you will use to reach it will be linear. If it is not linear, then it doesn't matter whether you reach net zero by 2050 or not. What you emit totally might not correspond to the probability of limiting warming to 1.5 degrees Celsius. It's like saying, I will promise to stop smoking in the next 1 year, but I won't tell you how many cigarettes I will smoke, in that 1 year. It's not about when I start smoking, but about how much I smoke in the journey towards stopping smoking. That is going to determine both my health and the health of those around me. Right? So in that sense, the timing of net zero is not really, it is a necessary condition, but it's not a sufficient condition. For example, if I don't have a linear reduction in emissions, if the emissions in fact increase or slightly increase and stabilize in this decade and then start reducing, then the year of net zero must be much earlier. It can't be 2050. It has to, in fact, be 2040 for us to be able to limit warming to 1.5 degrees Celsius. If the emissions reductions are much faster, if it's front-loaded emissions reductions, instead of waiting for technology to come up in the future, I decide that I will, front-load emissions reductions, then there is much more time. There is a longer tail that you see here. There's much more time to reach net zero emissions much later. Right? So in that sense, there is this entire hullabaloo around net zero is only at best, if I'm being very generous, I would say that at best, this is only partial science. It is not the full science. It doesn't matter. If the UK says that it's going to reach net zero by 2050, what is more important to me is how much are they going to emit in the meantime. If you're going to expand and explore more oil and gas, reopen coal mines, then irrespective of whether or not you reach net zero by 2050, what you emit before the time that you reach net zero is going to take up a large part of the carbon budget, similar to what has happened in the past. So for example, for a 50% probability of 1.5 degrees Celsius, 4/5 of the carbon budget is gone. The historical emissions are around 2,470 gigatons of CO2. What's remaining from 2022 onwards? In fact, this is remaining from 2020 onwards. So what's remaining from 2022 onwards is even lesser. And this number has been further revised by later studies to be much lesser, even than 400 gigatons. This is for a 50%, 50-50 chance that we will limit warming to 1.5 degrees Celsius. A large part of this is actually coming from what are quote unquote developed countries, so countries of the global north. The US, for example, is responsible for 17% of the emissions with only 4% of the global population. The European Union plus the UK responsible for 12% with only 6.5% of the population. All the other Annex 1. Annex 1 are the developed countries as classified under the UNFCCC. Basically, it is the OECD countries plus the economies in transition, countries of the former Soviet Union. So 13% of the, so other than the EU and the US, the other Annex 1 countries are responsible for 13%. China, with 17.5% of the population, is still responsible for only 10%, which is lesser than the proportion of the people on the planet that they support. India, far lesser than the number of people that we support on the planet. Similarly, for the rest of the world, which is the rest of the developing countries, it's 28% of the carbon budget with 47% of the global population. Right? So a large chunk, over 60% of what has been emitted till 2022 has been by developed countries with only 16% of the global population. And this has continued even in the last few decades. So the entire question that, historical emissions, we should not take into consideration historical emissions. For example, the United States has argued for the longest time that we can't be held responsible for what we didn't know. So if we didn't know that climate change was happening before 1990, then can you hold us liable for our emissions before 1990? Now, that argument cuts both ways. If you've benefited from something, even if you didn't know about it, then you have a higher responsibility to do something about the problem. But in any case, even if you just count the emissions from 1990 onwards, the developed countries have still consumed a lion's share of the global emissions. But the narrative in the climate policy discussions is that we must focus on global ambition for 1.5. And so this is something that you hear from the BBC, from the Guardian, in a lot of the developed New York Times, the developed country newspapers that speak about how there should be, you need global action, you need a global response. The focus must be on a global ambition. And there is no discussion of the fact that in terms of development, the UK, for example, is many, many years before, ahead of India. So, for example, I remember in Glasgow, when the COP26 happened in Glasgow, and India's Prime Minister announced that we will commit to net zero by 2070. The BBC had a program that evening saying, oh, it's 20 years too late. And mind you, the UK has announced that it will do net zero by 2050. So if the UK is saying 2050, India saying 2070 is very, very ambitious, because the gap in terms of development is over 150 years between the two countries. Right? So if you just look at per capita emissions, you look at other kinds of development indicators. But the gap between net zero is about 20 years. And even that gap is being criticized by a lot of the countries. But because that is the political narrative. Now, don't look at historical emissions. We must have forward-looking. Future warming is going to be because of future emissions. Let us already forget, for example, that we would not be having this discussion if we were not already at 1.1 degrees Celsius. Any discussion on equity is considered to be a barrier to ambition. So, if you talk about equity, you are putting up barriers. You're using it as an excuse to not be ambitious in mitigation. And of course, have global targets, global reductions. So 43% reduction by 2030, net zero by 2050, tripling of global renewable energy, 60% reduction by 2035, peaking before 2025. All of these numbers that are now part of the discussions are basically coming from the IPCC. And where does the IPCC get these numbers from? It gets them from integrated assessment models. And they are the narrative is that these are global numbers. Right? It doesn't matter. We are not saying how much who should do. These are global numbers, but global numbers imply some kinds of regional constraints. And in the IAMs, the global numbers are a result of you have a global optimal, but the world is not, even in the IAMs, is not considered as one entity. You have it divided into either 5 regions or 6 regions or 10 regions. And the assessment is done as an optimal across those regions. Right? So the integrated assessment models, there are multiple definitions online. I'm sure that, most of you are aware of what, at least have heard of the IAMs, even if you may not have worked with the IAMs. But they typically integrate macroeconomic models, either of the general equilibrium variety or the partial equilibrium variety. Energy models, which look at least cost optimization models. So you try and see what is the cheapest way to reduce energy. And vegetation models, which model the land use dynamics. This is a relatively newer part, because it's no longer possible to meet the kind of constraints that you have in terms of temperature just by shifting energy use from fossil fuels to non-fossil fuel based energy use. So you need to have large amounts of carbon dioxide removal, and this therefore needs you to be able to model some of the land use and land use changes, degrees of afforestation, reforestation, deforestation, urbanization, and what all of this means for the amount of sink that you have available to remove carbon dioxide. So if you consider 500 gigatons of CO2 as all that is available, there is a certain assumption of how much you're assuming the removal to be. But if you assume the removal to be 200 gigatons, it means that you can actually emit 700, not 500. The more you assume your carbon dioxide removal to be, the more you artificially inflate the amount of carbon budget you have for the fossil fuel and energy industry. So I will sort of, because I'm running out of time, I will, and I have quite a bit more to cover. What I will do is I'm going to skip some of the scenario storylines, etc., because what the models do is, so you have these ensemble of models, all of these three components provide Earth system, then the vegetation models, etc., lead to an emissions outcome, which has, of course, a certain amount of, implication for radiative forcing, which then means that there will be certain temperature increase and impacts of climate change, etc., impacts on different ecosystems. So you integrate the earth systems, the economic systems, so human systems, physical systems, and natural systems are integrated in this kind of an analysis, and that's why they're called integrated assessment models. Now, the first thing that has been done, and this is now, the IAMs have been around for a long time, and they've been used in different ways in different assessment reports of the IPCC since the beginning. But in the AR6, in the last assessment cycle, what was used was something called the shared socioeconomic pathways. Now, these are what they call baseline pathways, and they are narratives for the future of how you think the world is going to grow in the future. And these baselines are projected in the future. Now, there are certain assumptions that are embedded in these baselines themselves of how you imagine the future is going to be. Right? And the entire idea is to define it in terms of whether it's going to be a future that has a higher adaptation burden, a higher mitigation burden, or a higher or a lower mitigation burden and a lower adaptation burden. So the idea is to project a world that is in some sense defined in terms of mitigation and adaptation. That is one. The other is, it's one thing to create a story for how I want the world to develop, whether I want a more equal world, an unequal world, and things like that. But at the back of the mind, I mean, all the people who have, for example, constructed these storylines and contributed to these storylines have their own integrated assessment models. Right? So the idea is that eventually when you try to quantify the storyline, you're going to quantify it using an integrated assessment model. And so the storyline itself has to fit into a certain, format, a certain way. So you need to have certain kinds of demographic assumptions about capital, assumptions about labor, assumptions about, savings rates, or whatever it is, the kinds of assumptions that go into any kind of neoclassical models, so that you will be able to eventually quantify. And they had 5 such different storylines. And on top of these storylines, what you superpose is the least cost mitigation burdens. So least cost pathways or least cost optimization is done to look at how should the mitigation burden be distributed. So if you have only 500 gigatons globally, then how much should each region do? If I have 10 regions, how much should each region do? So I have a baseline that itself also has some elements of mitigation embedded in it. So if I assume, for example, high amounts of demand side reduction, a very large amount of efficiency improvements or a different kind of behavioral changes. So these are embedded in the baseline. And on top of that, I superimpose a least cost optimization to be able to find where is it that my mitigation should happen, meaning where is it that I deploy renewable energy, where is it that I do CDR, and so on and so forth. So you have these two elements together, resulting in the global modeled outcomes that you see in the summary in chapter number 3 of the working group 3 report of the IPCC's 6th assessment report. These are then numbers that are taken out without the entire range of qualifiers. So let me take a step back and say that there are some of these results of these models are published in papers, right? And there are, of course, discussions about what are the limitations, etc. There are some amounts of caveats. Not everybody puts caveats because there are a lot of modelers who think that the models really answer every question there is to answer in the world. And that's really a danger, sort of a dangerous thing to do this kind of modeling, because you start believing that your models can answer every question that there is to answer. But There are, of course, those who do provide a significant number of caveats. Only a part of those caveats are carried into the IPCC's assessment of that literature. An even smaller proportion is carried into the SPM of the IPCC's full report. The caveats completely go missing when the media reports whatever it is that is there in the IPCC's SPM. And there is a huge fight once again to get any kind of caveats when you want to take these numbers and use them in the policy discussions and the policy outcomes under the UNFCCC. You won't see the caveats that you see even in the IPCC report. You won't see them in the UNFCCC decisions. So it is this idea that science somehow has to be conveyed without any discussion of the uncertainties about science. But it's not just uncertainties. When it comes to IIM outcomes, the results are egregiously inequitable. Right? The scenarios assessed by the IPCC, they basically preserve continued global inequality across all variables. Variables for income, energy, emissions, consumption, etc. Even fossil fuel use, I will show, is per capita fossil fuel use is projected to be higher in developed countries even in the future. And so none of this is basically discussed when these results are taken as is and used in climate policy discussions. These caveats go missing. And if you actually want those caveats, the reaction, especially from developed country governments, and civil society and academia, is that, oh, you are trying to discredit the IPCC, you're trying to discredit the science. But a science that perpetuates inequity, in my view, is not good science. Forget the best available science. It's not even good science, because good science, foregrounding questions of equity and justice, I think, are essential for doing good science. It's not as if you ignore equity, you are being objective. And if you actually have equity, you're being subjective and you're, being normative. So it's not science anymore. In fact, most of these IIMs have embedded normative assumptions. They're all neoclassical in nature. It's a narrow subsection of the economics, entire economics discipline that does this kind of economic projections. And even economists as a entire fraternity, even with the divergences amongst them, are also only a subset of what you see in the real world. So to say that this somehow coming from one quarter, one small fraction of the academic society is somehow the best available science, when it projects these kinds of inequalities for the future, I think is quite a problem. So these are some of the results, which I'm going to again go through very quickly. The per capita GDP, for example, the C1 scenarios are scenarios that correspond to 1.5 degrees Celsius, 50% probability of limiting warming to 1.5 degrees Celsius with no or limited overshoot. So you have per capita GDP, if you look at sub-Saharan Africa, goes from $3,000 to $9,000, whereas for North America goes from $54,000 to $72,000, even for Western Europe from $34,000 to $52,000. So the rich get much richer. There is some amount of increase in incomes for the poor, but not even enough to be able to meet basic levels of income that would be needed in the future for basic human development. One thing that I think must be said very clearly is none of the scenarios, not a single scenario, meets the Sustainable Development Goals. Not a single scenario assessed by the IPCC. And it's not even, it was not on nobody's radar as well to say, okay, let us at least try and construct a scenario that meets the SDGs by 2030. The one scenario that tries to talk about the SDGs meets only part of the SDGs only in 2050. The SDG goals are for 2030. Right? So they only meet it by 2050. So, and the answer for why this happens is, of course, that, it's not pragmatic. Incomes in Africa and South Asia are not going to increase at this particular, at a very high rate. But you don't have the same kind of pragmatism when it comes to technological determinism. Right? You can have huge amounts of carbon dioxide removal and net negative emissions technologies, the deployment of negative emissions technologies that you assume for the future. but any assumption of equity for the future is considered to be not pragmatic. So there are normative choices that everybody makes. And my normative choice when I do modeling is to assume that equity is possible. Whereas technology, I don't know. Some technology might work. I do think that we need technological solutions. Some may work, some others won't work, but meeting equity has become much more urgent because of the crisis that we face. You have similar projections for per capita GDP, even in the 2 degrees Celsius scenarios, which tells you that income projections for the future do not come from constraints on emissions or the carbon budget constraints, but these are inherent assumptions in the models themselves, in the baselines constructed using these models themselves that are projected for the future. And on top of that, you impose a mitigation constraint. So you assume that incomes are not going to increase. And then on top of that, you assume that there is going to be a higher mitigation burden, even though your incomes have not increased. So this is like a double thing. So for per capita consumption of goods and services, which is a component of GDP, the differences are even worse. You have much higher increases in North America and Western Europe from already high levels, and very less for Sub-Saharan Africa and South Asia and developing countries as a whole, both in C1 and C3 scenarios. GDP continues to be very strongly correlated with energy throughout the time period in question. And so what you see is a large difference between per capita energy consumption in the developed and the developed countries. So on the left of each graph, of each section of scenarios, you have the developed countries in red and the developing countries in regions in blue. And you see a huge difference between energy consumption in North America and Sub-Saharan Africa and South Asia. And this is, of course, supported by a continued higher, everybody's fossil fuel use reduces. So coal consumption, for example, reduces for everybody. For China, it reduces at the fastest rate, much the most. It reduces for everyone, and it reduces from very low levels for Sub-Saharan Africa, Latin America, and especially Sub-Saharan Africa and Latin America. Sub-Saharan Africa goes from 3 to 0. None of the developed countries go to 0. If you look at North America and Pacific OECD and Western Europe, these regions continue to use coal even in 2050, whereas Sub-Saharan Africa is expected to go to 0. You have similar trends in oil consumption and gas. And so with total fossil fuel consumption, you have developing countries, the poorest regions of the world, Sub-Saharan Africa and South Asia, go from less to even lesser. Whereas North America, Western Europe, etc., go from very high to a little less. Right? So in that sense, you have continued inequality even in fossil fuel consumption well into 2050. But while, so there's high amounts of renewable energy as a proportion of total energy deployment assumed for developing countries, but the carbon dioxide removal, both through carbon capture and sequestration, as well as land use, so afforestation and things like that, happens in the developing countries. So, across all models, these are all different integrated assessment models, a large proportion, one is the total amount of CDR that is assumed in the models is mind-boggling. These are fairy tale numbers, so it's more than in some cases, more than the total carbon budget itself. 457, for example, is a huge amount of carbon dioxide removal that is assumed, and even the least. So if you look at 169 gigatons is huge amounts of carbon dioxide removed, right? We've not seen numbers like that at all historically or currently, and it all comes from a huge dependence on speculative technologies, not considering what the impacts are going to be. So what the assumption is that large amounts of land in developing countries is going to now, especially in Africa and South Asia, is going to be diverted towards energy crops. These energy crops then will lead to whatever negative emissions through BECCS. But this diversion of land, it's very clear. The IPCC report itself cites papers that shows this very clearly, that this kind of diversion of land is going to increase the risk of hunger and is going to increase food insecurity in these regions because of various reasons in these regions. the current trend of reducing risk of hunger is going to be reversed. And you're going to see increasing risk of hunger if you have these levels of carbon dioxide removal deployment. But of course, that is, you don't see that anywhere in the summary for policymakers. It's buried in the chapter somewhere in the IPCC. So as a result, what you have is a much higher mitigation burden on sub-Saharan Africa as compared to any other region. As the poorest region of the world, has the least amount of increases in incomes, has also the highest amount of mitigation burdens. Now, in which world is this an acceptable solution, an acceptable view of the future that we want to see? It's not at all clear. And when you use these numbers directly as inputs to climate policy, this is in violation of the principles, the values and principles that every country has agreed to under the UNFCCC, which is that climate action must be on the basis of equity and CBDRRC, common but differentiated responsibilities and respective capabilities. So why is it that models make these assumptions? I don't have time, but there is that part of the reason is also the models, the neoclassical assumptions embedded in the models themselves, the narrow interpretation of welfare economics through as Pareto optimality. So you can't have any distributive justice in the models as they stand. Economic inequalities, if you don't freeze them, the modelers themselves accept that the problem of underdevelopment will overwhelm the problem of climate change. Least cost optimization. So if it is cheaper to keep people poor than to reduce fossil fuel use in the rich world, then that is the solution that climate models will give you. Right? So if you look at what is the cheapest thing to do, irrespective of what the implications of doing that cheap thing are going to be, then it doesn't matter what the impacts are on the poorest parts of the world. And then eventually by the IPCC itself, why is it that they sort of take these models in a particular manner? The way in which the IPCC assesses and vets some of these is that you look at, what is reasonable, quote unquote reasonable for GDP, for income and things like that. But anything goes for technology. There is no vetting for reasonableness when it comes to deployment of negative emissions technologies, the rates at which you are going to see energy transitions to renewable energy in the poorest parts of the world, the rates at which you can reasonably achieve efficiency at very low scales of production itself in poorer parts of the world. And any assumptions, all the scenarios that assume less CDR, assume that there are certain kinds of changes in diets that people make, which is basically moving to Lancet diets by 2050. Now, what is the implication of the cost of a Lancet diet, going to nuts and things like that in developing countries, is of course not up for discussion. So current models and scenarios are unacceptable, and I am going to just take a few more minutes, the last few minutes, to present some kind of an alternative, and maybe that can be discussed more in the question answer session. Current models and scenarios are unacceptable. If you look at all the discussions in the text, before the numbers or after the numbers, there's a lot of language of how you need radical change, transformation, etc., etc. But this is not translated to operationalizing even poverty eradication and meeting basic goals such as zero hunger across any of these models. There's a misrepresentation of science to serve political agendas. Net zero is a classic example. There was the idea that you should have targets not for net zero in some year in the future, but for how much of the carbon budget is actually your fair share. What is it that you've overused in the past? What is it that you have, you need to, how much can you not exceed in the future? All of that has to be part of the discussion. Net zero is a red herring. It's it's an escape route in some sense. The next one in this net zero was in the AR6. The next one in AR7 is going to be overshoot pathways, right? Pathways that you overshoot 1.5 degrees Celsius and then come back to 1.5 degrees Celsius. But the only way to do that reasonably is to remove large amounts of carbon dioxide from the atmosphere using as yet speculative technology. There are, of course, people who say that, you can have this amount of things. So you have an unequal scenario and freeze any kinds of transfers of wealth in the models themselves at the beginning. But then outside of the model, post-processing, you say, okay, but if you want to achieve this, let me, you need to have financial transfers from developed to developing countries. Now, what good is money if you're going to say that I can't use that money to become richer in the poorest parts of the world? You're saying that my incomes have to be limited, because unless my incomes are limited, my energy consumption is not going to be limited. And unless my energy consumption is not limited, I won't be able to meet that energy consumption with the kind of energy mixes you're talking about. Right? So, but if you have that finance, so, what do I do with money in India? I burn it and cook my food on it. So unless it translates into material, energy that can be supplied to people, it's simply talking about financial transfer in the abstract and outside of the modeling is of no use. So what we need is a new framework for modeling equitable and climate compatible futures that looks at what is necessary as we go forward over what is pragmatic. And what is pragmatic, of course, is up for discussion always. Why is it that extreme levels of technology optimism are pragmatic, but any kind of hopeful view of a future, hoping for a world, or trying to imagine a world that is more equal in the future, is considered to be not pragmatic? So equity now, especially given the kind of impacts we're going to face, has become an urgent, has become urgent. And imagining, modeling, building, and achieving equitable and climate compatible futures is necessary. So I don't think I have time to go over this. So what I'm going to do is just quickly sort of talk about the framework and not the results so much. What we did was we took a large amount of developed, we decided not to use IAMs, not to go the IAM route. We took a large number of development variables and reclassified countries in development groups based on these development variables. We then had, scenarios that we constructed for energy. So we calculated energy thresholds. There is a lot of literature on decent living standards, sufficiency, and things like that. We looked at development correlated with energy requirements, and not just basic basic developmental variables such as infant mortality and things like that, although these are also included, but also infrastructure variables. You're not going to need roads, you're going to need schools, we are going to need hospitals, we are going to need infrastructure, housing for people in developing countries as well. It's not something that developing countries can do without, simply because historically we have had none of this, so we are used to it, and so we need not provide it to the populations in developing countries. This is an inherent assumption in existing IAMs. So we correlate energy projections to some of these requirements and construct scenarios for energy convergence for the future. Similarly, we construct GDP scenarios as well. These are growth scenarios, also degrowth scenarios, especially for developed countries, SDG scenarios and aspirational scenarios for the future in terms of economic projection. So they don't come from some neoclassical assumptions about what is the substitutability between labor and capital, because these assumptions are in any case also normative. My economic projections come from what is aspirational for at least for a majority of the people in this world. And then, of course, these on top of these, we impose climate constraints, which are budget constraints. These are not constraints of emissions reductions or net zero or whatever. These are budget constraints, and look at what happens if countries have to stay within the fair share of their carbon budget. And we estimate what is the amount of decoupling that you would need between energy and GDP, and what is the decoupling that you would need between emissions and energy for you to be able to achieve both climate compatibility as well as energy equity. So within that framework, we have a certain set of results, and this is the classification of regions, and I don't have time for the details, but I'll just show one last this thing. So this is, for example, I can't see the, this is my energy GDP, I think. No, sorry, this is energy emissions decoupling in this decade, 2020 to 2030. If you look at the United States as basically has to do 100% reduction, which means it has to go net zero. It is in the group G1, which is the highest development group. It has to go to net zero in this decade itself. China, which is G2, has to also do quite a significant amount of emissions reductions in this decade itself. Not emissions reductions, but this is energy emissions decoupling. So the ratio of energy to emissions has to reduce by 6% in this decade. And even for India, which is in G3, for the 1.5 degrees Celsius target, there has to be some amount of energy emissions decoupling. Kenya, however, which is part of the LDCs, the least developed group, does not get a mitigation burden in this decade. It is actually only starts mitigating from the next decade onwards. So, sir, you have these. This is the, sorry, this was the energy emissions decoupling, and this is the energy emissions decoupling for different temperature targets. So if you compare the United States across different temperature targets, the higher the temperature target, so the more, so if it's not 1.5, it's 2 degrees Celsius, the lesser is the mitigation burden. But the United States has a mitigation burden which is higher than what its currently observed rates of emissions reductions are, irrespective of the target being 2 degrees Celsius. So even for a 2 degrees Celsius target, what the United States is currently doing is not adequate. This is China. China has a target, again, for all of these different, for this decade. What is it that China must do? For 1.5, 1.7 with a 67% probability, 50% probability, and 2 degrees with a 67% probability. So across all of these, China has to do much more for 1.5, but its current observed rate is about minus 1.1. United States is energy emissions decoupling is slower than China's, with much higher amounts of per capita GDP in the United States. Its energy emissions decoupling is slower than that of China's and is much slower than what it actually must be. So for all the talks of 1.5 degrees Celsius being the North Star, etc., one of the worst performers in in terms of meeting targets is actually the United States. This is India and Kenya. Of course, as expected, you have lesser burdens on India and Kenya because they're G3 and G4, less developed countries. But the burdens become even lesser if you have a higher temperature target. But if you want 1.5, then there is a burden, not significant, but there is a burden even on India in this particular decade. Right. This is the emissions reductions and decoupling levels that you require across the 4 countries that belong to these 4 regions in the 3 decades between now to 2050. So 2020 to 30, 30 to 40, and 40 to 50. Right. So if you look at the United States, 1.5 degrees Celsius, it must go to net zero this decade. 1.7 degrees Celsius with a 67% probability, its net zero comes in the next decade, between 2030 to 2040. For China, for 1.5, the net zero is in the next decade. But for 1.7, the net zero is in the later decade. And progressively for India and Kenya, net zero is further. So this idea that net zero for everybody has to be 2050, even for the 1.5 degrees Celsius target, that's not true. So for example, for the 1.5 degrees Celsius target, Kenya does not need to still, if it gets the fair share of its carbon budget, Kenya need not go to net zero before 2050. It can go to net zero later. Similarly for India, it can go to net zero by 2060 if it gets a fair share of its carbon budget and it manages to front load some of its mitigation and not leave it for much later. So this entire idea that you have somehow everybody has to reach net zero by 2050 is politically, it's a violation of the principles of the UNFCCC and its Paris Agreement. But it's also scientifically something that is not necessary. You can imagine mitigation for the future in a different way so that you actually operationalize the principles of equity and CBDRRs. So this is, I think, my last slide. I'm going to say that higher efforts are needed from all, but much higher efforts needed from rich countries. Paying lip service to transformation is not useful. We must operationalize it in models, and not just in models, but also in reality. Pragmatism, reasonableness cannot be a justification for projecting continued poverty and deprivation for the global South. And at the end of the day, a lot of this, it goes beyond simply an academic discussion. Every time I talk about this, a lot of my colleagues say that, you get very worked up when you speak about this, but I get worked up because it relates to the real lives of people all over the world, the lives of the working masses, their futures, their aspirations. It's not simply an academic debate. It is a real political debate, and we must not shy away from the fact that it is. So I'll stop here. Thank you.
Thank you ever so much, Taydel. Unfortunately, we didn't unmute ourselves quickly enough for you to hear our round of applause. We might do another round of applause.